Taking out those gives.
I mean, why couldn't you do that? Just add t delta s to both sides. Then you're never multiplying or dividing through by a negative. Right, and then you would divide both sides by s, delta s. Is delta s defined as negative in this problem? Yes. So if delta s is defined as negative in this problem, you would have to flip the inequality, and that's why it actually matters. But you haven't done it yet, have you? Oh, you did. Okay. So
It's like 4 negatives.
all right, here's where it is. This is where it is. So when you rearrange the equation without the numbers in it, and you're like, oh, I'll just divide both sides by delta s, which does not appear to be negative when you're not putting the numbers in, then you're good, and you don't ever switch the sign. But if you're going to have to plug in first, so that when you divide both sides by delta s, and that's a negative, you just flip the inequality. Ooh. At least we figured that out, because I'm just like, well, I rearranged for what I want to solve for, and I never divide through by a negative, but I did. I just didn't have it plugged in yet. So, yep.
Okay, so because those are both negative, you're putting them on the other side, you flip the sign.
You have to flip the sign.
So
When
can I
you
still
divide
use this
through by
equation?
delta s, yeah. When you divide through by delta s, you're dividing through both sides by a negative number, so you flip the sign.
Now, I checked my work in the answers book,
Uh-huh.
and that's what I got, but that's the wrong way the sign
So
split.
there's 2 different ways to do
Yeah.
it, and you would get 2 different answers technically.
Hold on. What do you get?
So I think this
Solve
is
it
one
out
of those
and then let's
things
figure
where
it
you
out.
have to use common
Did you
sense to
flip this
determine
one?
the correct answer. Because we know that
There should be a
decrease
math
in
way. You
order
shouldn't
should be a
have to have any
decrease in
common sense
temperature.
for
So
math. That's not good. Alright, so if you just put the answer,
thermodynamics.
temperature is greater than.
So now I have a question concerning the test.
Wait, let's get this
Okay.
first. we get this far, hold on. Okay, so, I get 3,160 Kelvin. Now you've moved this to an equal sign, right? Okay, so temperature has to be greater than 3,160 Kelvin. That's what you're saying, right? All right, and
Why even decimal for centimeter?
temperature.
I converted it to kilojoules,
Oh,
because there's in joules to begin.
Right.
Oh, okay.
You have a unit problem in this problem because it gives entropy in joules and it gives enthalpy in kilojoules. All right, so let's dig into the math here. We've got
Don't worry, Austin.
Yeah,
You're not the only one
Yeah, I know.
confused.
less than
But I'll
that,
probably be
and
wrong
that's
because
good.
we don't understand both sides. They are
All right, hold on. So when I divide through here, I'm gonna flip the sign.
situations kind of thing.
Okay, so here it is. When I divide through by delta S, I flip the sign. So if I don't put temperature on the other side, I would get this. Temperature is less than this, because delta S is a negative number in this situation. It's negative that.
And normally it wouldn't matter with the equal sign because this is
Right.
the direction.
Right. So
So I guess it's better to input the numbers first then.
Yeah.
you have to input
I
the
arranged
numbers
it.
first.
But
This
I
is
put
what
the
we
numbers
learned.
in first, and I
Little
still got the wrong.
backwards to the T.
Well, I guess it depends how you do it. It's the way I did it. My first attempt, I just left the T and the delta S on one side, and then without worrying about the negatives, then I input the numbers and the negatives cancel on both sides,
Yeah, that's what I did.
and then the T's just stayed there. So, and then moving it, the temperature was less than.
It's ugly.
I still don't
So
understand.
temperature
Well,
is
that's
to
not high
be less
temperature.
than 3,160 Kelvin for this thing to work. It's ugly.
Because I rearranged the number away from the T.
But now that we know
Plug
where we put
in,
what, then it's
like,
not going to be so hard.
Don't even move that equation from its standard form without plugging all your numbers in, and hopefully then it will go okay. Alright, so,
I still don't understand. Because I put in my numbers first and it still didn't work.
so you have enthalpy
Mhm.
minus temperature times this negative guy, which you converted, and that's good.
So
It's
did
less than,
the two negatives cancel each other out? So then you make this positive?
not
No. Okay. What order do you do stuff in?
good.
So I subtracted or added that to both sides.
Then you divided both sides by that, right?
Yeah.
And then
And so that should have flipped the sign there
that
because it
should
was a
flip the
negative.
sign because you're dividing by a negative.
Okay, so I didn't flip the
So
sign
flip
there.
the
That's
sign
what I
there.
did.
And then get
Okay.
rid of
And then when you multiply by negative, fix it when it flips the
flip
other way.
again.
Okay, that's what.
Does it actually work now?
Yeah, I think so.
With it. Temperature is less than, okay. Oh my
Okay,
goodness.
so I just didn't put my sign.
That's too much sign flipping for me, but this is correct and rather nightmarish.
So, in another column, you just plug in the numbers in the equation, in this equation right here.
Plug into the one up top there, the blue one.
Okay.
In its standard form, plug in like that. And then every single time you multiply both sides or divide both sides by a negative number, flip the inequality. And remember that you should get a negative delta S for a negative delta H on the test. I do not have the other two problems, and I have no idea where my copy went. I might need to see your book.
Actually, I might have to ask you because I didn't do it, so.
Oh, Brittany's up, and yeah. Okay. Are we filming me fumbling around for this? 'Cause I hate when that happens.
Yep.
Great. I'm glad I can't find my paper on camera. That's wonderful. Oh well. All right, Brittany, let's get it done together.
Do you want to see this way? Or,
Fingernail polish or something.
okay, so, is there activation energy from this point to, this point here?
So you always go, activation energy is from the energy of the reactants to the top of the ball.
That's what I thought, but maybe I looked at a different roundabout use. So it was just like the 1500 minus the 200.
Mm-hmm.
Okay, that's 1300.
And is it positive or negative? Always positive.
I know.
Okay, so she says activation energy for 9 is positive 1300
Yeah.
kilojoules.
I mean, literally,
And, delta H,
It depends on what kind of test it is for me.
is it 11? Because
I'll buy that. Let me look
it's
at it.
from this point to that point.
Yes.
Yeah, okay.
So she's going for, well, maybe, I don't know.
I think that's.
Yeah.
You like 13.
So if I ever tell anyone,
13.
answer it right away.
So here's the answer for 9.
Send them the
She says
slides.
activation energy is 1300 kilojoules. Delta H is 1100 kilojoules. So is that guy endothermic or exothermic, Brittany? That's endothermic because it's products of high energy. Yeah.
I got a slightly different delta
That's
H.
fine because you're just eyeballing a graph. So I would have
just do that too.
I would have put that right on 1200 too, but you can make a case for that being slightly different than 1200. So and Maddie. Oh, it even asked that. Look at that. Is the following reaction spontaneous at 298 Kelvin? So spontaneous means what do we need?
That's the Gibbs.
And what does Gibbs have to be for it to be spontaneous? Gibbs has to be negative.
That's not bad.
So you just kind of use Hess's law like, you use an equation like Hess's law with Gibbs instead. Which I'll write while you're doing it. So,
Yeah, it's in the textbook and then it's in the appendix.
Yeah.
And it's the biggest paragraph in the text.
and while she's putting this one up, if you want to take out everything you want to turn in, I will scooch by and grab them. Lab reports, test corrections, stuff you made up while you were absent.
If you'd like, I can email that to you also.
That's okay. Yeah, I'll keep the printout. The only thing, if you email me a lab report, ideally I should grade it fast, and you should do that if you really think you've messed up. That's fine.
Here's my one.
I'm taking Maddie's lab, so she shouldn't have to worry. Especially at the beginning of the year when people have never written a lab report before, they're like, and it might be good to email it then. But for now, I think you guys are all pretty well under control. And grab the ammonium dichromate sheet. And as soon as we get this one done, break into groups of 2 or 3. Make sure everyone has at least somebody to talk to. And start on that. Did I give you a balanced equation? We might have to start. We'll start out together. Oh, I give you this stuff. All right, so Maddie, calculating delta G. I'm putting up a balanced equation, which I don't actually have, so I'm looking at this. So we've got
would this be at 0? Because these two would be because they're gas. But I cannot find the...
Oh, we're doing Gibbs. Because to find out if it's spontaneous, Gibbs has to be negative, so you don't need to load that entropy for Gibbs. But yes, apparently Gibbs is 0 for elements, just like enthalpy is. So for the products, there's only one product, and it is so she's got 6 moles of the one product, and then there's only one reactant to consider because the other 2 are elements, and Gibbs for an element is 0. You flip this over and start working these rated balanced equation.
Yeah, the answers are right here. You just gotta read them.
Wow. Nice, okay.
I don't know what to say. I'm assuming this is a solid.
Ammonium dichromate is a solid, and I will build a little thing to house it because it is. Well, when you learn about redox reactions, you'll see that hexavalent chromium is super bad, which is what this is, and it's very dangerous. Cancer-causing, ugly.
Don't forget we need goggles.
Yes, and you will want to stand downwind also. Very bad.
Okay, so that's
This box. But the product is no longer hexavalent chromium because we reduce it or oxidize it. I'm not going to tell you which because you have figured that out in module 16 anyhow. And so it's much safer in the end than it is in the beginning.
Okay.
here, I didn't use a box, and I ended up having to blow for chapter parking lot to turn it into a safer product. So, I'm gonna do that again. Okay, so Maddie's got a negative delta G, so is it spontaneous? Yes, negative delta G tells us it's spontaneous. I have no answer too, so what do we think? Anyone have an agreeing answer with
Yeah,
that?
I have the exact same one.
Wonderful. Then we will go with oh, here, I have old answers. Yep, negative 1300 kilojoules is correct. Okay,
I did this.
she did it. Perfect. Okay.
I'm so lost. I have no idea what I just did.
You just calculated Gibbs, and if it's negative, it's spontaneous. And if you got a positive answer, it would not be spontaneous. Oh, here's my answer sheet. Hooray. So yes, as long as it's negative, it's spontaneous, and that is what you're after. Just is the answer positive or negative? Okay. So hopefully you've looked at the first line here for the ammonium dichromate volcanic. It says ammonium dichromate decomposes into chromium 3 oxide, nitrogen gas, and water gas. Right? Balanced equation. So, does anybody have one yet?
Yes.
Go ahead and put it
All three
up.
of us have it.
Well, you put it up. You're in the end. They have to jump over the detritus I left over there. So while he's putting up a balanced equation, number 2 says, why is the enthalpy of formation for nitrogen gas 0? Lily?
Because nitrogen is in its elemental form.
Yeah. Nitrogen's an element or some similar answer. Perfect. So number 3 says, write the Hess's law equation. Why can you use Hess's law in this case?
What does it mean that Hess's law equation?
Like delta H equals the sum of delta H of the products minus the sum of delta H of the reactants.
Okay.
Like, I just want you guys to practice writing the equation so you don't get to the test and go, what was that equation?
Okay. I thought it meant
Oh.
the problem.
No, it might be, well, yes, you're going to write the problem next. And in that little gap, so save room. But I just can't remember things anymore, so I have to write the equation 6 times before I can remember it for the test. And I will instantly forget it and have to look it up again later. So why can we use Hess's law in this case instead of having to do bond energies?
Because we know all of the forms.
We know all the phases.
Phases.
So hopefully in the equation here, look, we've got ammonium dichromate, which is a solid, decomposes into chromium oxide, which is a solid, nitrogen gas, and water vapor, because it's hot. So you're going to calculate delta H. I just told you it gets really hot, so you should expect a negative one. You have a chart on the page, so go ahead and plug into Hess's law and find the enthalpy for this equation. And talk to your lab partners, and we'll come back together once we basically have an answer. If you get done, go on to calculating delta S, which is the other half of the chart. Hess's law. Calculate enthalpy. for the sake of speed. I don't know. If you're filming, please stop because this is boring.